All right, this is chi-square's test of homogeneity, scenario number 2, page 233 of the note spiral. Surveys of drivers of differing age groups were taken to determine if, and notice we have a plural here. That might be indicating that we have multiple populations. If the driver had been in an accident during the previous year, and if so, was it a minor or major accident? The results are tabulated below. Is there evidence that the accident type varies by age? Now, if you notice here, once again, we're looking at this table and we go, you know what? I have a table here. I have multiple rows and columns. We know that makes it a chi-squared, but we're not sure. And also because it's multiple rows and columns, it's not going to be a chi-squared goodness of fit. This is either going to be independence or homogeneity. So when I look at this, I mean, if it's chi-square test of goodness of fit, then I'm going to have one column, or excuse me, two columns and one row. I can't have, one of them has to have one row or one column. I can't have multiple rows and multiple columns. One of them is going to have to be singular. Because I have multiple rows and multiple columns, this is either chi-square test of independence or chi-square test of homogeneity. Nowhere within this do I see anything that indicates that it is a test of independence. I don't see the word independent. I don't see the word dependent. I don't see the word association, and I don't see the word relation. As a consequence, I believe this is probably going to be a chi-square test of homogeneity. And they want to know if it varies by age. The fact that I have multiple surveys sounds like I have multiple populations. So they've broken this down and set this up as a chi-square test of homogeneity. So in this particular case, once again, HO, and they want to know whether or not it varies by accident type, varies by age. See, the accident type or the accident type proportions are the same for each age group. And you want to work the word proportion into a homogeneity test. Alternative, the proportion of accident type is not the same for each group, for each age. All right. Now, please remember, we like having these as in equal. R is equal, is not equal. So the next thing we need to move on to is we go ahead and we're going to look at this and sit there and go, what is our conditions? And the first condition is independent random samples. Independent random samples. And they didn't tell us that is not given. Assume that the surveys represent the population. I hope they do, otherwise we're in trouble. N is less than 10%. So we're going to need to add all these up. So let's add them up anyway. So 67 plus 42 plus 75 plus 56 plus 57 gives a total of 297 right here. Then we have 10 plus 6 plus 8 plus 4 plus 15 is 43. And then we have 5 plus 5 plus 4 plus 6 plus 1 is 21. 21 plus the 43 plus the 297 equals 361. And 67 plus 10 is 77 plus 5 is 82. Forty-two plus 6 is 48, plus 5 is 53. 75 plus 8 is 83, plus 4 is 87. 56 plus 4 is 60, 66. And 57, 67, 72, 73. Check this out again. Oh. 82 plus 53 plus 87 plus 66 plus 73 equals 361. So our rows and columns sum up. That's good. All right, the next thing, we need 10, n is less than 10%. So 361 divided by 0.10 equals 3,610. Reasonable to assume that there are more than 3,610 drivers. N is less, the sample size is less than 10% of the population. The next thing, the expected values. Expected values greater than or equal to 10, see table. And we'll take care of that in just a moment. And the last one, observe values are counted data. Okay, so we have our conditions done, but we need to take care of the expected. So when I do this and go 297 times 82, go 297 times 82 divided by 361, I get 67.463. Because remember, this times this divided by this, and I can do that for each one of them, or I can use the matrix. So let's jump into the matrix real quickly and put this in. And we have 1, 2, 3, 4, 5, and 1, 2, 3. So our degrees of freedom would be 1, 2, 3, 4, 5, 5 minus 1 times 3 minus 1. So this is 4 times 2 is 8. Our degrees of freedom would be 8 in this case. Well, let's go ahead and run this thing, because this is going to be an interesting case, because remember what our third condition is. We need expected values greater than or equal to 5. So 5 enter and 3 enter. And so 67 enter, 10 enter, 5 enter, 42 enter, 6 enter, 5 enter, 75 enter, 8 enter, 4 enter, 56 enter, 4 enter, 6 enter, 57 enter, 15 enter, 1 enter. Now, it's okay for an observed value to be less than 5. but our expected values can't be. So these are observed. So this is okay so far. So second quit, stat, test, chi-squared, chi-squared test, observed, expected, calculate. There's our values. I'm going to come back to that in just a moment because I want to go back and check my expected values. And I go to matrix B and I look and I go, I have a problem. So I'm going to copy these down, but real quickly, I notice not all of them are greater than 5. So I have a problem with running this test right now. Now we're going to fix that problem. And to be truthful with you, I've never seen them require this, but they could. It is part of the curriculum, and it's not that difficult to do. So this is 43.604, 71.576, 54.209, 60.058, and then we get to 10, and we go 9.766, 6.313. This is 10.363, 8.615, and so far everything's greater than 5. So far we're good. Now this is 4, but it's not the expected. The expected was 8, so we're good to go. Oh, the expected was 7, I'm sorry. This was 7.8, wrote the wrong value. And then this is 8.69. But this row, we start running into problems. 4.7, too small. This is a problem. That's a problem right there. It's less than 5. 3.08, that's less than 5. 5.06, hey, that's okay. This one's fine. But then we have this one. This should have been 3.8, too small. And this one is 4.24, and this is too small. So we have these groups right here that are too small. Too small, too small. So what do you do? At that point, you're going to have to combine. You're going to have to go ahead and break these down and combine them. And I need to combine them in such a way that I see that I have more than 5. Well, 3 plus 4 is 7, so that looks like that'll be more. That's already more, so I'm good to go. And what if I combine these two? Well, that's more than 5. So let's break it down this way. Instead of under 18, let's say less than 25. And we're going to have our table. So we're going to have our less than 25 group. We're going to have, this one was fine. 26 to 40 was good. 26 to 40. And then we're going to need to do the over 40, so then the greater than 40. And what did we have? We had 0 accidents. Well, if I combine these two, it's going to be 67 and 42. I combine those two, and now I have 109. So I'm going to combine those, and I have 109. This would be my observed. I'm going to do the observed in black. We left this one alone. That's 75. But now we're going to combine the 56 and 57. 56 plus 57 is 113. So that's observed. Minor. And then over here at the very end, I have major. I don't know that I gave myself enough room, but we'll have to deal with what I have. So there we have major. Make 0 way too big. So we combine 10 plus 6, 16. The 8 we left alone. 4 plus 15 is 19. And now 5 plus 5 is 10. 4 plus 6, 4 is fine. We leave it the way it is. 6 plus 1 is 7. Now remember, that's less than 5, but we don't care about observed. So now I'm going to have to re-enter the matrix. So I'm going to go second matrix. I'm going to re-enter this thing. And now I have a 1, 2, 3, 1, 2, 3. I have a 3 by 3. So 3, enter, 3, enter. And now the first 109, 16, 10, 75, 8, 4, 113, 19, 7. Now let's run this thing and see if everything's greater than 5. So second, quit. And we're going to go stat test, chi-squared test. We calculate, and we're going to go second matrix, edit, drop down. And guess what? All my expected values, and I can go ahead and record them, are all greater than 5. This is 111.07. This is 71.58. This is 114.36, 16.08, 10.363, and 16.56. This one is 7.85. This one is 5.06. Just needed to be 5. It barely is, but it's good enough. It's over 5. And this is 8.09. All right. So now we've satisfied our expected value condition. This did not satisfy it, but when we combine them together, that did. So we're doing a chi-squared test. Chi-squared equals observed minus expected squared over expected. And in this case, the first one is 109 minus 111.07 over 111.07. That's squared. Don't forget to do that. They will ding you for that. And that came from here. The next one is going to be 7 minus 8.09. And when we run this test, stat test, what did we get? We got a chi-squared value of 2.07, right? And our degrees of freedom they calculated for us, but let's go ahead and show how they did that. They went rows minus 1 times columns minus 1. So 3 minus 1 times 2 minus 1 degrees of freedom. 3 minus 1 is 2. 2 times 1 is 2. So our degrees, excuse me, this should have been 3 minus 1. 3 minus 1 times 3 minus 1. So 2 times 2 is 4. Degrees of freedom are 4. They gave us a p-value. It's a very large p-value. 0.722. Alpha, 0.05. This is greater. So our decision is going to be fail to reject the null. And once again, you could have actually done this again with the second vars. Second vars, chi-squared, CDF. Our T statistic, 2.07. Degrees of freedom was 4. And we get the 0.722, all right? So, our conclusion, our p-value is 0.7223. We fail to reject the null. there is not sufficient evidence at alpha equal 0.05 to suggest that the proportion of accident type is not the same for each age group. This part, the proportion of accident type is not the same for each age group, that came straight from the alternative hypothesis. What does this mean in reality? All right. We cannot conclude that accident severity varies by age. Because that's what they ask. Is there evidence that accident type varies by age? All right, and we cannot conclude that accident severity varies by age. There's some evidence, but there's not enough evidence. Matter of fact, there's not very much in this case. We ended up with a very, very large p-value. All right, we had a very, very large p-value. All right, that concludes this one. Thank you. Oh, you know what? Before I conclude that, let me say one more time. I have not ever seen them require you combine, but they could require it. And you can actually combine whatever you want to, but make it make sense. It made sense to go, you know what? Let's combine under 25. This group already satisfied, so we didn't need to combine it. And this one's like, okay, we're going to make them over 40. And then it worked out pretty well. All right. So thank you.